Biomass Briquette Business, a complete beginner's guide. Introduction. Imagine if the crop waste that farmers usually burn in their fields could instead become a profitable business worth crores of rupees. Imagine converting sawdust, sugarcane bagasse, rice husk, cotton stalks, or groundnut shells into a clean industrial fuel that replaces coal. This is exactly what the biomass briquette industry does. As industries across India search for cleaner and more economical alternatives to coal, biomass briquettes have become one of the fastest growing renewable energy businesses. The best part is that this business not only generates profits, but also helps farmers earn additional income, reduces air pollution caused by stubble burning, creates rural employment, and lowers carbon emissions. In this video, we'll cover everything you need to know, from the raw materials and manufacturing process to machinery, investment, profitability, government support, and the future of the biomass briquette industry in India. Let's begin. 1. Biomass resources and raw materials. The foundation of every briquette plant is biomass. Biomass simply means any organic material that comes from plants or agricultural waste. India produces hundreds of millions of tons of agricultural residues every year, and a significant portion remains unused. Common raw materials include sawdust from sawmills, sugarcane bagasse from sugar factories, rice husk, wheat straw, cotton stalks, groundnut shells, mustard stalks. Each material has different characteristics. Good briquetting material should have low moisture, reasonable bulk density, and a high calorific value. Moisture content is especially important. Ideally, biomass should contain around 8 to 15% moisture before entering the briquetting machine. Selecting the right raw material and ensuring year-round availability are among the most important factors for a successful plant. 2. Briquette manufacturing process. The manufacturing process is surprisingly straightforward. First, biomass is collected from farms, sawmills, or industries. If the material is too large, it is crushed into smaller particles using a crusher or hammer mill. Next comes drying. Excess moisture reduces briquette quality and machine efficiency, so rotary dryers or flash dryers are used whenever necessary. After drying, the biomass enters the briquetting machine. Under extremely high pressure, the material is compressed into dense cylindrical or square briquettes. No chemical binders are required for most biomass materials. Natural linen present in plant fiber softens under pressure and acts as a binder. Once formed, the briquettes are cooled, stored, and finally packed for transportation to customers. The entire process converts loose agricultural waste into a dense, clean-burning fuel that's easier to transport, store, and use. 3. Types of biomass briquettes. Not all briquettes are the same. Depending on the machine and application, different shapes are produced. The most common are solid cylindrical briquettes. These are widely used in industrial boilers and furnaces. Another popular type is the briquette with a central hole. The hole improves airflow during combustion and provides more uniform burning. Some manufacturers also produce square or pillow-shaped briquettes for specialized applications. Briquettes also vary according to the raw material used. Sawdust briquettes are known for their consistency. Bagasse briquettes are common near sugar factories. Rice husk briquettes offer an effective use of agricultural residue. Each type has different ash content, density, and calorific value, allowing industries to choose fuel according to their requirements. 4. Machinery and plant setup. A typical briquette manufacturing plant consists of several machines, raw material handling equipment, crusher or hammer mill, drying system, storage bins, briquetting press, cooling system, conveyors, packing system. Depending on the raw material, additional screening or mixing equipment may also be required. Plant size depends on production capacity. Small units may produce 1 ton per hour, while larger commercial plants can produce 5 to 10 tons per hour or even more. Briquettes are used across many industries. Textile mills use them in steam boilers. Food processing industries generate process heat using briquettes. Paper mills, chemical plants, brick kilns, dairy plants, and pharmaceutical companies also use biomass fuel. Many captive power plants co-fire briquettes along with coal. Hotels, educational institutions, and community kitchens also use biomass briquettes in suitable heating systems. The biggest advantage is that briquettes produce lower emissions than coal while offering competitive fuel costs. As industries work towards sustainability goals, demand continues to increase every year. Economics of briquette manufacturing. Now let's talk about profitability. The economics depend mainly on four factors: raw material cost, transportation, power consumption, selling price, seasonal availability of biomass, fluctuating raw material prices, high transportation costs, moisture control during monsoon, machine maintenance, competition from coal prices. Maintaining consistent briquette quality is also essential because industrial customers expect reliable fuel performance. Successful manufacturers overcome these challenges through long-term supply agreements, efficient logistics, proper storage, and regular preventive maintenance. Future of biomass energy in India. The future of biomass energy in India looks extremely promising. Industries are under increasing pressure to reduce carbon emissions. Coal prices remain volatile. Conclusion: biomass briquettes are much more than compressed agricultural waste. They represent a circular economy where farm residues become clean industrial fuel. Farmers earn additional income, industries reduce fuel costs, and the environment benefits from lower emissions. Whether you're an entrepreneur, engineer, investor, or simply interested in renewable energy, the biomass briquette industry deserves serious attention. If you found this video helpful, don't forget to like, subscribe, and turn on notifications. In our upcoming videos, we'll explore each topic in much greater detail, including machinery selection, plant design, investment calculations, raw material sourcing, and real-world profitability. Thanks for watching, and I'll see you in the next video.